I hope that you guys are having a great Tuesday. I hope that you guys have any questions or have some questions for the exam upcoming on Thursday. Um, and I hope that I can answer all of your questions. Now, what I'm going to do today is I'm going to give you kind of a rundown of what to expect and maybe some important topics. I've got a list of topics that I've used to build the exam and to write the exam. And what I'm going to do is share those with you. But before we get to specific topics that the exam will cover, I want to make sure that everyone's prepared to, kind of go through, well, what should you expect on Thursday? Um, and if at any point you have a question, please don't hesitate to ask. I'll do my best to answer them as we proceed through. Oh, lengthy private message. I had some trouble with the Proctorio practice quiz. Is there any way you could make another practice to make sure my computer will work for the exam? I was able to eventually do the practice quiz, but it kept kicking me out after getting in. I'm worried I might get kicked out of the exam multiple times. Um, Make another practice. I'm not sure I follow that part because I believe the practice exam should you should have a lot of attempts at it, and that should address that. Proctorio practice quiz. Sorry, I meant practice Proctorio version. Yeah, you have 99 attempts at the practice. Oh, the practice exam. Okay, so I meant practice Proctorio version. Now I'm getting mixed up. Do you mean the practice exam or the Proctorio? Are you trying to? Yes, the practice is not proctored. Not intending for it to be proctored. You want it to be proctored? Is that what you're asking? I want to make sure my laptop works for Proctorio. Yes. Okay, so you would like me to make the practice exam administered or proctored by Proctorio. Is that correct? So, um, yes, that or either just one quiz question that is proctored. Yes. So I have on our Canvas site, I have what you're asking for actually. If you follow this link, everyone, that will take you to the Proctorio administered practice quiz. So this has one question. This is how you can ensure that your computer is good to go for Proctorio. So that has been up, that is up until December 10th. So that's something that you can practice, you can try throughout the semester. Is that what I tried, but I couldn't attempt it anymore? Okay. Well, yep, you clicked the wrong one. Okay, good. I'm happy we could clear that up. Okay, everyone. Is there a key to homework one, or when should we expect to get feedback? Would this exam one PowerPoint be available on Canvas? That's a great question. I'm actually going to be building this up as our class is proceeding, so I'm going to post this after class. Is there a key for homework one, or when should we expect to get feedback? I will post the key for homework one before the end of tomorrow. Is the homework graded on accuracy or completion? Largely, the homework is graded on accuracy. I'm not going to be, yeah, so it is graded on accuracy. I noticed that the practice exam had questions over muscles and more content than the learning objectives. Should we consider what is on the practice to be on the exam or just the learning objectives? I would focus primarily on the learning objectives. Okay, so if there's something that goes beyond the scope of those, then that's what you should, sorry, you should just rely on and fall back on the learning objectives. Okay. Um, okay. So muscle contractions will, yeah, that will be on the muscle. We talked about those, and that would fall into a subset of the learning objectives. We talked about muscle contractions. Is there a list of all the learning objectives? I noticed that not all of the days have them. I will have a compiled list and share that with you guys later today. Will the exam be curved? I do not curve exams, and I curve the grades at the very end of the semester. Okay. So I'll talk about grading in just a little bit. I didn't see them on the learning objectives. Didn't see muscle contractions. Since it's something that we covered in class and muscles, just 1 second, and I'll look at and anything after. So I'm looking at learning objectives for tertiary and quaternary structure. Okay, protein being injured. Okay, so I started to put the learning objectives on the 16th so that you guys could have a preview, and I'm going to be continuing to do that over the course of the semester. Um, in terms of, and I'm going to add and make this a more comprehensive list of learning objectives. So this right here will be updated later today with everything that you should expect to see. But in addition to that, what I'm going to be going over today will be, you could look at this as like, okay, this is our comprehensive list of learning objectives, what I'm going to be going over today. Give me a why if that makes sense, and you're good to go. Okay, great. Okay, great. So here's what we got. Um, that link is going to be updated a little bit later today. Now, a couple of things that I want to clear up. So your time frame for your exam. This exam is going to be administered during class, and with that though, our time frame for the exam, do one thing. Um, from 12 p.m. until 52:20 p.m. is whenever our exam is going to be available. You will have 60 minutes for the exam. It will be administered as a Canvas quiz with Proctorio. Now, at the same time, I will be on Zoom in our regular lecture link. If you encounter any issues during your exam. Now, I'm going to go back because there's a couple of details that I want to add. For starters, 2:20 p.m. is when the exam closes for everyone. What that means is that if you start your exam at, say, 2:05 p.m., can anyone add to the chat how much time you will be able to take your exam if you started at 2:05? 15 minutes. So do not start your exam at 2:05 p.m. Now, that's the lockdown. Everything, it will stop. It will pause. It will stop you. And it will say something like you've been kicked out of your exam or something of that nature. Now, with that said, the 60 minutes for the exam, I did not write, or I will not be giving you a 2-hour exam to be taken in 60 minutes. Do you think it's something we'd be able to finish between 12:30 and 2:20? Okay, so I'm happy that you asked that question. Um, if you start, actually, look, since you have 60 minutes for it, if you start your exam at 12 p.m., what time will the exam stop for you? 1 p.m. So if you started at 12:05, it closes at 1:05. Can you give me a Y in the chat if you follow that, the time framing? Okay, great. Now, Proctorio. Um, make sure that you have completed the Proctorio practice quiz. I would do that either today or tomorrow. So if you encounter it, so to resolve any issues before test day. Now, I want to go to Proctorio itself altogether. So some things to anticipate. With Proctorio, it is a browser plugin and needs to be installed to work. If today, whenever you go and try to practice the Proctorio quiz or do the Proctorio practice quiz, if you are prompted with enter access code, that means Proctorio is not installed. So some responses. I'm just using ASDF as a placeholder because I'm going to be tabbing over. So some kind of appropriate responses to that. Try to install Proctorio. That's the first. Second, try a different web browser. Try Chrome if you're not using Chrome. I know lots of folks like to use Safari just because, oh, I have a MacBook and Safari's preloaded. Try using Chrome. Proctorio does require a webcam and access to your microphone. So those are two things that can happen or can give you kind of a headache. So if you don't have a webcam, you need to resolve that before Thursday. One option is to look into, I know that the library rents out materials for people to use. And I believe that a webcam is an eligible piece of technology that you can rent from the library. I could be wrong, but try to do that. If and chances are, if you have a laptop, you probably have a webcam already installed. Um, now, one thing that people always ask about Proctorio, and I understand why, um, is they're a little bit unsure about, well, what happens? Like, what is my computer doing? What's Proctorio doing? Well, Proctorio will record your exam, your activities on your screen, and it will provide me with a report and a log of your activity while taking your exam. So that means that if there's somebody sitting next to you and they're like, "Oh, well, I'm looking on my phone and I'll just tell you the answers," or, "Oh, yeah, if if you do this while taking your exam, Proctorio will notify me." Now, with that said, Proctorio does not adjust your grade, or nor does it assign your grade. Proctorio will flag your basically your testing experience, testing session, and give me a link, and will suggest that I review it. And it will give a score. It will say something like, and when I say score, I mean a confidence score, not a here's how you did on the exam score. It will say like Proctorio has flagged this because there's a 100% chance that this person was cheating. Um, so there's that. So just be thoughtful about your surroundings. If you take your exam in a public place, your microphone and the video is going to pick up people in that public place, and then it will flag it. I will look at it and I'll be like, well, you're taking your exam at Mochas and Javas. There are people there. Um, Next up, are we allowed to have scratch paper during the exam? Yes, you are allowed to have scratch paper. Okay. Now, next, I got a private message. So it will flag each time we're looking at our note card we use? Yes, it will. But again, that has no impact on you. It will just report it to me and say, hey, Joel, take a look at this. Now, can everyone give me a 7 in the chat if you understand that you'll be allowed to look at your note card and it has no impact on your testing experience? Great. Okay. So as easy it is for me to say, I understand that it's not that trivial for you guys to be like, oh, yeah, I feel completely comfortable with this. But do your best to not stress about, well, is it going to flag this? Is it going to flag that? Because chances are it is. But again, I'll scrub through the video and I'll be like, well, this person's taking their exam. That's all there is to it. They're taking their exam and they have a note card that I've allowed. Now, with that in mind, you have a 3x5 note card slash piece of paper that you can use. You can write anything, and just a minute, I'll get to that. Thank you very much. That's a great question. Anything and everything that you want on this note card. I've had people say, oh, does it have to be an index card? Does it have to be? It does not. And I'm going to show you in just a moment what is a good idea. You can use the front and back of one note card slash piece of paper. Now, like I was saying, Proctorio will notify me to review your video. And I will, and then I'll say, well, it looks good. They did they did what I asked them to do and what was within the parameters of like fair activities during their exam. So no issue. Um, with that in mind, your first exam question will prompt you to hold up your note card showing the front and back for approximately 5 seconds each. The next thing is this needs to be a physical paper item. Then the last item is that blank scratch paper is allowed. Okay. Now, with all of that in mind, I want to make kind of a proposal for what people have done in my class in the past whenever I've aborted the note cards. So I'm using PowerPoint right now. And what I've seen people do that I think is a really good idea is to get the rectangle tool. Now, with the rectangle tool, it allows you to draw somewhere on this slide. And I'm going to draw this box right here. And then what I'm going to do is I'm going to show you guys that look over here. You have the dimensions for that. So what I'm going to do is where I have those dimensions, I'm going to put the height at 3 and the width at 5, fulfilling my 3 by 5 index card. Then what I'm going to do is I'm going to go to shape outline and I'm going to switch it to black outline. Shape fill, I'm going to have no fill. And then what I'm going to do, rather than using the front and back, I'm going to copy and I'm going to paste. And then whenever I get that, effectively this gives me my two 3 by 5 pieces of index card, or my two 3 by 5 index cards. Does everyone follow that? Give me a Y or an N in the chat. Okay. Now, as soon as you have this, the convenient thing that you can do is, and this is where this has to be a printed thing. And the reason for that is if you make something that's 3 by 5 on a phone, you can zoom in, zoom in, zoom in. You can put literally every single slide within that if you adjust the resolution. Now, what you can also do with this is you could get a text box and you can type amino acids. You could type that. Adjust the sizing of that. Let's put that at a size 5 font. Now that's really small, but let's see what happens whenever I print this slide. Just a second. It's coming. Slide 5. And I just updated my printer's firmware because how often do I print something? Very infrequently. But I've got this on there. This is something that I typed. It looks small to the naked eye right now on my computer, but now I've got my printed document. And if I look closely, I'm like, aha, I can read that. So size 5 font I can put on there. And so then what I'm getting at is you could copy and paste whatever pictures you want on here. You can do whatever you want within this 3 by 5 space. And here is my two 3 by 5 index cards. Now, with that in mind, if this is the route that you elect to go, and you get that 3 by 5 piece of paper, or sorry, if this is what you do, this is not an arts and crafts class. So I'm not going to require that you cut this out and piece it together. However, if whenever on exam or on the first question, if you're showing this and you're like, aha, I wrote here and I wrote here, that means you cannot write in this white space prior to the exam. Because if you put information here, and then put information here, give me a Y or N, are you using something beyond the 3 by 5 provided space? Yes, you are. So are you actually using a 3 by 5 note card? Give me a Y or an N to the chat. No, you're not. So that would be an honor code violation. And that would be something where I'm like, listen, it just reminds me of I don't know if you ever had this in elementary school, but if the principal was like, hey, you guys can we're going to try. We're going to give a test run here of you can chew gum at school. And then after a week, oh, well, there's gum all over all the desks. We tried it, we can't do it. So right within this space, not the white space, though. Can you give me a 9 in the chat if you understand that? And if you're confused about that, please send me a private message. Okay, so you can put whatever you want within there. I think that it'd also be a good idea, like when you print a slide, yeah, I've got this as 3 inches by 5 inches, but whenever you're printing something, you've got your margins, so that scales things down a little bit. Make sure that you're using the entire provided space. Um, Now, with that in mind, let's go ahead and I'm going to give you kind of a rundown of the composition of the exam. So the exam is going to be 35 questions. And based on my calculations, let's see, 35, 100 divided by 35. We're going to be at about 2.9 points per question. Now, about 30 are going to be, or are, multiple choice. 5 questions are multiple select. So, multiple select questions. I want to give you an example of what that looks like. A multiple select question would look initially like a multiple choice question, but it's going to be worded a little bit different. And with multiple select questions, you can select more than one answer option. Now, with that in mind, it might be something like select all of the single letter codes for polar uncharged amino acids. Okay, so now as a multiple select question, this would say polar uncharged. So our polar uncharged would be something like Q for glutamine, then let's say C for cysteine, then D for aspartic acid, K for lysine, and S for serine. Now, let me first indicate the correct answers. So this is worth about, just like all of the other questions, is worth about 2.9 points. You would get full credit for this if you selected the Q, if you selected the C, and you selected the S. That would get you full credit. Now, if you selected, and actually, I'm going to go ahead and add one more thing on here. Um, hey, okay. Just to make the math as direct as possible, um, I'm probably, yeah, just to have the math as direct as possible, I'll probably have one right answer for every wrong answer. So roughly. Now, the important takeaway for you guys, though, is this is what it looks like. Full credit is awarded if you select Q, C, and S for this specific question. Now, if you were to select, I'm sorry, I need to move my slide deck over. If you were to select C and D, if you were to select those two, no credit. The reason being is that one of those is correct and one of those is incorrect. So it's sort of, well, one step forward, one step back. If you selected, I'm going to change colors just so I can keep this as or a little bit more clear. If you selected Q, C, and D, that would get you, in this case, since there are 3 correct answers, that would get you 1/3 credit. If you selected, let's go with indigo. If you selected Q, C, D, and S, look at that drawing, Joel, good job. You selected all 3 corrects plus 1 incorrect. That would mean, or that would result in 2/3 credit. Okay. Can you give me a Y or an N in the chat if you follow that? Great. Okay. So I think that's kind of the place where it gets a little bit confusing for folks on the grading of those sorts of questions. Now, does anyone have any questions about the logistics of the exam, what they should expect on exam day? If so, you're welcome to ask to the whole group or just to me. You can unmute yourself. I've got my speakers on. And if you're writing it, just go ahead and write your question, send it as a private message if you'd prefer. Um, but this Proctorio practice quiz, this is absolutely important to do. I have two questions over the practice exam questions. Can we hold questions about that until a little bit later? Or if you send me a private, or if you send me an email with those questions, I can get back to you as soon as possible. Okay. Or if you just want to, I'd like to get through the exam review first. I think we are a lot. I think we aren't allowed to have any amino acid structures on the index cards, right? Are you asking me? Let's go back to boom, anything and everything. If you want to put them on there, go for it. That's your, think about it as there's space that you're using. So if you put your amino acid structures on both sides of this, well, then you're sacrificing space for other things. If you put your pKa values, that would be a total waste because I'm going to give you your pKa values. So you don't need to worry about those. Does that answer your question? Good, 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 good. Okay. So, um, all right. So topics that you need to know. Single letter amino acid codes. Three letter AA codes. Structures of AAs. Classification of AAs. Components of AAs. And let's see, our last but not least regarding this would be Margaret Oakley Dayhoff. Um, these are all important things to include. So you need to know your single letter amino acid codes. We've got 35 some odd questions, and some of those questions might be as kind of concrete as select the full name for R. It might also be select the three-letter code for R. It might also be here's a structure. Which amino acid is this? Now, whenever you look at these first three items, think about these as things that I want you to be using interchangeably. So your three-letter codes, you should be able to convert those to structures. Structures, you should be able to look at your single letter codes. Single letter codes, you should be able to come up with the three-letter codes, the full names. In addition to that, classification. So just as we saw with this hypothetical question right here, select all of the single letter codes for polar uncharged amino acids. I want you to be able to, based on your knowledge of the classification of amino acids, I want you to know the connection between single letter codes and classifications. So that's important information. Be able to like juggle and jump back and forth between these. In terms of this, your 3x5 card, I'm not going to put A is for alanine, which is for ALA. The reason I'm not going to do that is because that's an easy one to remember. And whenever I say that's an easy one to remember, I mean, if you know the rules of how amino acids got their single and three-letter codes, this is going to be one that's a little bit more straightforward than some of the others, like K for lysine, Lys, or D for aspartate, which is ASP. Okay. So, given these three options of what would I want to include on my slide or on my 3x5 card, I'll use the K and the D because those are unique. They don't follow the pattern of first letter is your single letter code. So I'm going to be judicious when it comes to adding that information to my 3x5 card. Next up is classification. There's major classes. You've got your polar, uncharged, polar negative, polar positive, and you've got your nonpolars. In addition to these, you also have your aromatics. So I will ask questions about all these different groupings. Components of amino acids. What I mean by this is N, C, C. I want you to know these functional groups. We've talked about them a lot. If I were to say, if I were to give you this structure, and then I were to say, right, A, B, C, one of these, which one of these typically has a pKa of around 9? Now, there's a couple of different ways you can answer that question. One, I'm going to give you the pKa values of every amino acid. So you can look at that and be like, oh, well, the C termini always has it. So the correct answer is, oh, wait, no, no, no. Okay. The correct answer would be A. Okay. That requires you to look at the pKa values as a reference and be like, okay, there it is. That's what I need to know. A is the correct answer. Alternatively, you could answer this just by remembering, okay, well, this is an amino functional group. This is a carboxyl functional group. Those are my two groups that are ionizable. And A has a higher pKa, roughly around 9, whereas B, that's not an ionizable proton. And C, well, that has a pKa of closer to about 2. Um, that would be a sort of question that would be like muscle memory that I'd want you to be able to, save yourself some time. Then another sort of question whenever it comes to components of amino acids. Um, what carbon is this? What is this carbon commonly known as? It's commonly known as our alpha carbon. So so there's your alpha carbon. This is the R group. And that R group is what designates your, polar uncharged or polar charged. Then last but not least, Margaret Oakley Dayhoff. There's only a couple of names that we've talked about in this semester, but Margaret Oakley Dayhoff is the woman who's responsible for or credited appropriately with, well, where did the single and three-letter codes come from? She was a bioinformaticist who worked on lots of computational problems and projects with respect to protein folding. And she is the one who basically came up with, well, if I'm programming this protein sequence, it's much easier to use a shorter identifier than writing out alanine, than writing out glutamic acid or glutamate or aspartate. So the three-letter and single-letter codes basically came from her work. Okay, next up in terms, or does anyone have any questions about these topics? If you do, let me know. Next up, peptide bonds and higher level protein, higher levels of protein structure. Okay. Now, when it comes to these two topics, well, this first one, it's not too tricky. Um, I do want you guys to identify if I gave you an amino acid backbone or a polypeptide backbone. I want you to identify which of these bonds, A, B, C, D, and E, which one of these is the peptide bond? Well, what I think is really helpful in visualizing this is to look at, okay, well, these three atoms make up the backbone of one amino acid. Well, this is a dipeptide. And and heck, you know what? Whenever I think of polymers, specifically thinking back to organic chemistry, a polymer is like one thing repeated over and over again. Well, if I look at this backbone right here, what I'm going to see is I've got one thing repeated a second time, or heck, NCC, a third time. So C is the correct answer. That is where my peptide bond is. Now, in addition to that, we talked about peptide bonds and some of the properties about them. Well, first of all, they are resonance stabilized. Duh. Resonance stabilized. Um, as they are resonance stabilized, they have they are fairly rigid, meaning that, well, they have limited flexibility. You're not going to see the um, you're not going to see those bonds, or you're not going to see the peptide bond move very much. Now, we did see some bonds that did change, and those were our phi and psi angle bonds. So the phi and psi angle bonds ultimately give us like the flexibility and movement of an entire protein structure, which is where we had this figure right here, where we talked about a what's known as a Ramachandran plot. And the Ramachandran plot that I'm showing here is basically showing the combination of angles that are possible. Now, what I mentioned about this was imagining that, your hands are those bonds. And if you remember, we did like let's imagine I rotate this and this in opposite directions. One of them went 90 degrees, the other went negative 90 degrees. Now, what I want you to remember about this figure right here is that these blue regions, whether it's the darker blue or the lighter blue regions, those are the regions of stability. So it's this combination of bonds that, or bond angles that make your structure more stable. I just had a moment where I was like, oh no, am I recording? I am, thankfully. So that's kind of our step from our primary structure, our amino acid sequences, to looking at the tertiary or the secondary structure. Now, before we go on from there, one of the things that I want you to, and I shared this with you, and it's important that you are able to do, is I want you to be able to calculate the PI of a peptide. I want you to be able to calculate the charge of a peptide. And I'm going to say calculate the PI of a peptide and an amino acid, individual amino acids, calculate the charge. And I'm actually going to go back and I'm going to say charge slash charges of a peptide and an amino acid. Now, in addition to that, I also want you to, if I gave you the structure of a molecule, and I'm going to come up with one real quick, and I'll copy and paste it into our slide deck here. The URL that I was using that I really like, or the tool that I really like, is pepdraw.com. I provided that link again. If I were to look at, say, RHLAE, there we go. Um, let's say I'm just playing around with some tool or some components of it. Print screen. I'm going to copy and paste this. Snagging picture now. Oh, there we go. Keep in mind, I will give you all your pKa values, but I will give you this structure as an example. I'm not going to tell you the sequence. What I want you to be able to do is to look at this and process this figure. Can everyone see? Can you give me a Y or N and if you see this peptide? Okay, just want to make sure that it copied properly. So, kind of in action, I might give you a question that is actually, at what pH is the molecule below likely at? So, in order to answer this question, the first thing that you've got to be able to do is you've got to be able to tell me what's the sequence of it. Because if you don't know that sequence, then you can't look at the pKa values and say, oh, yeah, it's protonated. Now, let's say that I've got answer options of A, B, C, D. Let's go with 1.5, 7.0, C. I'm going to go with 10.5 and 11. Now, I've got a pretty even distribution. Well, actually, I've got more basic ones, but this is the sort of question that I want you to be able to do pretty quickly. The N termini and the C termini, both protonated. The N termini protonated isn't radically impressive, but if these were your answer options, I'm actually done. I know how to answer this question because can anyone add to the chat approximately what's the pKa of the C terminal group? It's about 2. Okay. And give me a P for protonated or a D for deprotonated. Is this group protonated or deprotonated? It's protonated. So if this group right here is protonated, what does that mean about my pH? Well, that means that my pH is below that pKa. And if this pKa is approximately 2, well then I'm in shape. I know that A is my correct answer. So in this one, I didn't really have to come up with, well, what is the sequence? But how can I make this a little bit more difficult? Well, I can make it a little bit more challenging of a question if rather than asking at what pH is this molecule, what possible charges can this molecule have? And so this question of what possible charges can this molecule have? Well, then what I'm looking at is, okay, if I'm going to go ahead and operate under the idea that this molecule is completely protonated. I want to put together, well, what is my sequence? Now, in order to do that, I think the way that I approach this is I'm going to circle each of my peptide bonds. 1, 2, 3. 4. What I'm doing is I'm looking for my carbonyl oxygen and then the bond that follows that. Carbonyl oxygen, bond that follows. Carbonyl oxygen, bond that follows. Carbonyl oxygen, bond that follows. Those are my peptide bonds. I'm going to switch colors for a second so that I can then highlight my R groups. R group, R group, R group, R group. Oh, wait, R group. Skipped one. Sorry about that. Now, whenever okay, now what I'm going to do is I'm going to switch to purple. And I'm going to circle my ionizable R groups. Well, in this case, since I've got the molecule at a very low pH, ionizable, ionizable, ionizable. So I'm just looking at my ionizable R groups. Now, R, H, arginine, histidine, then this alkyl group right here, that's a leucine, that's an alanine, and that is a glutamic acid. This question says, what possible charges? How do you know that they're ionizable? I have looked at these amino acids just as I've asked you guys to look at the amino acid R groups and familiarize yourself with them over and over and over again. I've also played with PepDraw, this tool that I provided you guys the link for. So in addition to that, recognizing functional groups, the amino group and the carboxyl group. I'm familiar with these because we've been looking at them since the first day of class. So my N-termini, ionizable. So I've got a total of 1, 2, 3, 4, 5 groups. 5 groups that are ionizable. My molecule right now, what is its overall charge? Well, here's a charged group. 1, 2, 3. So this is a +3. So this molecule has a charge of +3 as it's displayed right now. I've got 5 ionizable groups, total groups, not just R groups, 5 total ionizable groups. So I'm going to draw an arrow for each one of those. That's 2 arrows. That's 3 arrows. That's 4 arrows. And then this is 5, so -2. So my molecule can have a range from +3 all the way to -2. Now, I don't have any more information to fill in right now because I don't have the pKa values before me. But if I did, what I would do is I would fill those pKa values in from the lowest to the highest. And then I could get these two and calculate the PI. So there's a lot that I can do with this sort of question. Can you give me a Y in the chat if that's something you'll be able to do when you take your exam? Okay. Now, is this something that you could put on? Give me a 5 in the chat if this is giving you some ideas of what important information you'd want to put onto your note card, or a W if it doesn't change anything, you don't know what to put on your note card. Okay. Now, if you're about to put a W but don't feel comfortable doing that, I'm glad to meet. I've got office hours tomorrow. I'm glad to meet, and we can kind of strategize and game plan about what would be worth your time to put on there. Okay, so this is one of the sorts of questions, and one of the things that I would recommend that you kind of play around with in terms of like, how should I study for this? How can I study for this? Use PepDraw. Use that tool, come up with a peptide, use your name, use like an object behind you or near you. Like, okay, my background is green. What does the peptide green look like? Green. What are the PKs? What are the possible charges? Play around with that sort of thing. That's why I like pep draw. Okay. Now, moving on from there, more exam topics. Yeah, so calculating PI, calculate the uh, charges of a peptide and an amino acid and the structure of a molecule. Then, secondary structure of a peptide slash protein. Um, then, what are the different levels of protein structure? What forces stabilize the different levels of protein structure? Um, then alpha helix and beta sheets. I'll say beta sheet slash beta strand. Um, then I will go on to, well, secondary structure disruptors. Disruptors. Okay. So secondary structure of a peptide, well, this is going to be your alpha helix and beta sheets. Your different levels of protein structure, primary, secondary, tertiary, and quaternary. I want you to know like a simple description of all of these. Do you know the definition of the secondary structure of a protein? Um, and I'm going to add the not or the degree symbol there because that is what we use for all of these. So your primary structure is just going to be amino acid sequence. Secondary structure are your local structures. Tertiary structure is the three-dimensional structure of the protein. And then quaternary structure is, well, 3D structure of more than one protein. Let me rephrase that to more than one peptide. I'm posting this PowerPoint. Yes, I am. Whenever I'm all done with this, I just wanted to build it so you guys are kind of a part of like the process, what to expect. So yeah, I will be posting this after class. Now, this prompt right here, I'm going to go ahead and fill this in right here. Your primary structure, your primary sequence, that is stabilized by covalent bond, specifically a peptide bond. Local structures are stabilized by backbone hydrogen bonding. So what that means is that if a R group is involved, that is going to be a part of the tertiary structure. What I mean by that is like if you have a serine, I'll go ahead and add in here, not serine R group plus backbone. That would not be a part, that would be not two different parts of the backbone interacting. That was a weirdly stated sentence. Give me a Y if that made any sense, or an N if you need to try again. Okay. Oh man, lots of N's. Sorry about that. So a serine R group plus backbone amide is tertiary structure, not secondary. Did that help at all? Okay. So let me go ahead and I'm going to grab a part of one of our other slide decks. So what I'd like to, or what I'm trying to kind of communicate is when you see a figure like this, what I want you guys to be able to do is to look at this figure and say, okay, well, I'm looking for, okay, first of all, I want to be able to follow my or kind of evolve and put together my different levels of structure. So this right here, what's depicted right here is an alpha helix. What's that? An alpha helix. Can you give me a one or a three? A one if you're good, you see that that's an alpha helix, or a three if you don't follow that. Okay. When you look at this sort of figure, what you need to be able to do is find, well, where is your primary structure? And the best way to do that is to look at NCC. NCC. Oh, sorry. I'm going to switch to highlight. NCC, 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 NCC. Can you give me a five if you follow that as your peptide backbone? Seven if you don't. Okay, great. Now I'm going to switch, and if you follow that as your peptide backbone, what you should be able to see is off of that, or an important part off of that, is these different R groups. Can you give me a W in the chat if you see those R groups? Okay. Now, when we're looking at the secondary structure of a protein, we're just putting those R groups in as an R, as a placeholder. Now, this R group right here, well, if this was something like serine, it would look like this, CH2OH. Now, is this OH, is that capable of hydrogen bonding? Y or N to the chat. An OH is perfect for hydrogen bonding. Okay. Now, if you would imagine that we've got CH2OH. Now, I'm going to use this rainbow pen to depict a hydrogen bond. So my OH here, let's say that it has a hydrogen bond from my OH on this serine. This is a serine. Okay. What I'm trying to, and what I want to convey is that here is a hydrogen bond that I've got the letter A linked to, and then here is another hydrogen bond that I've got the letter B linked to. Can everyone see the different hydrogen bonds A and B? Add a Y to the chat if you can. Okay. Now, this hydrogen bond that I've highlighted as A, that is a backbone hydrogen bond because this is going from the amide to the carboxyl end of the peptide bond. Can everyone see that? Give me a one in the chat if you see that, and give me a three if you do not see that difference. Or do you not see what that is? That's from the peptide, the backbone. Okay. Now, this hydrogen bond that I've labeled with B, B is not a backbone hydrogen bond because, well, it has the part of the R group of serine is one of the parts of that hydrogen bond. Can you follow that? Give me a Y or N in the chat if you follow that. Okay. So A would be secondary structure. B would be a part of the tertiary structure because B utilizes a part of an R group of one of our amino acids or one of the amino acid R groups. Can you give me a R in the chat if that makes sense and is more clear, or an O if it doesn't make any sense? Okay. Okay, great. Okay, so that's what I was getting at with serine R group plus a backbone amide is part of the tertiary structure and not a part of the secondary structure. So 3D structure of a protein, this is stabilized by R group interactions. Now that would be an R group, an arginine interacting with. So if the bond is not connecting the backbone, it is tertiary. If the bond is not connecting the backbone, it is a tertiary. If it utilizes the R groups, yes, that would be correct. So for a secondary structure, you have to have both of your hydrogen bond donor and acceptor, they both have to be backbone elements or backbone atoms. Great. Okay. So if you have an R group interacting with the backbone, that's tertiary structure. If you have an R group interacting with an R group, that's tertiary structure. Quaternary structure is the same thing. The difference between tertiary and quaternary structure at the end of the day, which is still R group interactions, but with 2+ peptides. So when it comes to tertiary structure, we're talking about one peptide. And when it comes to quaternary structure, 2 or more peptides. So those are the different forces that are stabilizing our different levels. Now, primary and secondary is a little bit more clear. It's like, okay, peptide bond or hydrogen bonding. Done. Can anyone provide in the chat what are some possible R group interactions and what are the different like types of bonding that could exist between different R groups? And in order to answer that question, you've got to know more about the R groups. You've got to know about their structures. We could have a disulfide bond. What if we had, so would the stabilization of the fourth structure also be R group? Yes. R group interactions. Oh, I'm sorry. The fourth structure is also through R group interactions or between two peptides. I'm sorry. Um, Remove the or, and that is the correct statement. Two different peptides, but R groups. So imagine this. This is a protein, and there's an arginine. No, I'm going to remove that. I'm going to go with a serine. Okay. And then here's another protein. And here you have a threonine. Okay. Do you see that those are two different proteins? Wire into the chat. Okay. Now, a serine looks like this, CH2OH. A threonine looks like this, CH2OH. Actually, no, that's the two R groups here, they both have hydroxyl groups, so they can hydrogen bond with one another. So imagine if you had two groups that were hydrogen bonding with one another, but that stabilized this whole thing. Does that make any sense? Give me a 1 if it makes some sense, or a 3 if it doesn't make any sense. Okay. So I would recommend, and this is why knowing your amino acid structures is so important, because these interactions, if you have let's say that you had an arginine All right, no, let's go with a lysine. Can anyone tell me the charge typically of lysine at a pH of 7? Just the R group. Positive. Now, D, that's aspartic acid. What is typically the charge of aspartate at a pH of 7? That R group is going to be negative. So if we have a positive, yeah, it'd be -1. So if we have a positively charged group and a negatively charged group, what type of bond is going to be formed between those two? An ionic interaction, an ionic bond. It wouldn't be a peptide bond. A peptide bond is a covalent bond. So we can have an ionic interaction between these two. And an ionic interaction is going to stabilize this tertiary structure between those two proteins. Now, if we had, here's another lysine, and here's a D for aspartic acid. Well, it's a positively charged and a negatively charged. Is this going to be stabilizing the tertiary or quaternary structure? Tertiary, because it's only one peptide. Okay. So, exam topics as we continue, we've got alpha helix and beta sheet or strand. Then we got secondary structure disruptors. Your two secondary structure disruptors are proline and glycine. The reason for these is that proline is too rigid and glycine is too flexible. Now, when it comes to additional information regarding protein structure, I want you to be able to do the secondary structure math. And what I mean by that is, well, we talked about what's this distance from here to here? That's about 5.4 angstroms. Then that would be one rotation. So your secondary structure math is all about questions like how many amino acids in one rotation? Well, that would be 3.6 amino acids. You have 100 amino acids in a peptide. How many rotations can you have? Well, that would be 100 divided by 3.6, which would give you, let's call it 30 something rotations, roughly. Okay. So those sorts of problems I want you to be able to answer. So that's primary structure, secondary structure, and we talked a little about tertiary structure. Tertiary structure is all about R group interactions. Quaternary structure is also all about R group interactions, but on different peptides. Now, what I think is helpful is to get like a piece of yarn or something like that and just imagine, okay, we've got these two pieces of yarn. How do they interact with one another? Well, if there's an arginine on one and there's a um, glutamic acid on the other, that would be an ionic interaction. What if you have a leucine and a leucine? Okay, well, in order to figure this out, you have to know leucine is could anyone add to the chat, how would you classify leucine as an amino acid? It's a nonpolar amino acid. If you have two nonpolar amino acids interacting, is that going to be an ionic interaction? Nope. Is that going to be a covalent interaction between two nonpolar amino acids? It's going to be a hydrophobic interaction. Two nonpolar groups. Now, with that said, I'll give you a little bit of a, thing to remember. When it comes to R group interactions, I'm going to go to a new slide. Only one amino acid is capable of covalent interactions. And that specific covalent interaction, only one amino acid, R group, is capable of covalent interactions. And that covalent interaction is a disulfide bond. Can anyone tell me which amino acid is capable of forming a disulfide bond? Cysteine. So can leucine participate? Can the R group for leucine participate in a covalent interaction? Nope. How about alanine? What about glycine? Are there any polar positive amino acids that can participate in these sorts of interactions? Nope. How would we classify cysteine? Cysteine is a polar uncharged amino acid. Okay. So this is where our classification, think about all this information as like being scaffolded. Like you have to know the amino acid 3-letter and 1-letter codes and their full names. Then you got to learn how they're classified. You have to know how they're classified. Can you put some of this information on your index card? Yes. But you got to be able to kind of bounce around with this information and understand the connection between this and this. Okay. Now, after that, what we're also going to be covering on this exam is a sarcomere. A sarcomere is basically that individual component of a muscle cell. Now, so any nonpolar interactions is hydrophobic. Yes. You put hydrophobic in quotations, and when you hear that word, what I want you to think about is breaking it down. Hydrophobic. Hydro meaning water, phobic meaning fearful of it. These nonpolar alkyl groups, these nonpolar groups, a bunch of carbons and hydrogens, they hate water. They love an organic environment, not an aqueous environment, which is what a biochemist lives in. So, a sarcomere, what are the components of a sarcomere? We've got the I band, the A band, the H zone, the Z disk, and the M disk. What are these different regions? What do they consist of? Well, an I band is only actin filaments. The A band is actin and myosin. The H zone, only myosin. And the Z disk is your bookend, we'll say, of a sarcomere. Your M disk is the midline of a sarcomere. What you also need to know about these is that you've got two other major proteins. You've got actin and myosin, but then you've also got titin and nebulin. Titan basically anchors um, is basically spans the width of anchors the Z disk to M line. Nebulin controls length of actin filaments. Now, in addition to all of that, I want you guys to know about, well, what happens when muscles contract and expand. So, this is a good figure for you to know about. Oh, sorry. Whenever the muscle relaxes, well, then you have less of the actin filament overlapping with the myosin head groups and the myosin filaments. What this also means is that your Z discs, when the muscles contract, the Z discs get closer to one another. Do your actin filaments or myosin filaments, do they ever change in length? No, they don't. So then how does this happen? Well, the way that this happens is through this sequence of events right here. We went from like 30, oh crap, it's 150. That's why. I was going to say, man, we went from like 40 people to now 31. Um, I want you to know this sequence of events. Sorry about that, everyone. What happens along this sequence? So we've got our myosin head group that is bound to, oh, dang it. Our myosin head group that is bound to an actin filament. ATP binds, which causes it to dissociate. The ATP-bound myosin dissociates from the actin filament, and then the head pivots and binds a new position on the actin subunit. Hydrolyzes ATP, releases an inorganic phosphate, then it releases ADP, and it's still bound to the actin filament. This process continues on and on so that that muscle can contract even further. Okay, so then there was some stuff about protein. Sorry, there was other stuff about tertiary structure, R group interactions, denaturants. All the remainder of that is going to be on this exam. So domains, denaturants, and I just can't stress enough the importance of knowing your R groups, and understanding how they work and what the interactions are. So there is a figure that shows this. How these different R groups exist and everything like that. Does anyone have any questions? I'm going to copy and paste some slides from previous slide decks into this before I upload it. Will I type the rest of the topics on this PowerPoint before you post it? Sure. If there is any hemoglobin and myoglobin, it'll be very limited. It'll be limited to like the functionality and the difference in structure. Okay, well, I'm going to go ahead and stop the recording. I'll get the rest of the topics on here